So yeah, essentially the idea is you want to, again, this is right when you see like miles per hour, 50 miles apart, average speed. We know this is going to be a rate problem. And whenever we get a rate problem, the first thing we're going to write down is D equals RT. Because like literally like in any rate problem, literally like the only equation you can use is distance equals rate times time, which is why like these kinds of questions aren't like that hard. Like for rate questions, because which equation you're going to use. Like it's always going to be distance equals rate times time, or at least most of the time it will be. So to solve this question, like, sometimes it might be a good idea to draw a pretty diagram, because like why not? So like you have Austin and Temple, and they're going to be 50 miles apart. And we know that while they were going this way, they were going at 60 miles per hour. And when they came back, they were going at 40 miles per hour. So we want to know, what is the average speed? Well, we know that the average speed is going to be, so average speed is going to be the distance divided by the time, right? So distance divided by time. We know distance equals speed times time. So if we divide by time on both sides, we know speed is distance over time. So what's the total distance that that Bonnie drives? Well, Bonnie takes drives 50 miles from Austin to Temple. That's 50 miles. And then Bonnie drives from Temple to Austin. That takes another 50 miles. So the total distance traveled is going to be 50 plus 50. Now, what's the total time taken? Well, when Bonnie drives from Austin to Temple, she's traveling at 60 miles per hour. So that tells us the time is distance over rate. So 50 over 60 is going to be the time it takes to drive from Austin to Temple. And then Bonnie drives back from Temple to Austin. So and she's driving at 40 miles per hour. So distance over rate gives us a time. So 50 divided by 40 represents the time taken to come back. 50 divided by 40. So this is the total time, 50 over 60 plus 50 over 40. And we can kind of simplify this. We see that the 50s cancel. So in the numerator, we just have 2. And on the bottom, we have 2. So we have 2 over 1 over 60 plus 1 over 40. And just fun fact, this is called there's a special name for this. This is actually called the harmonic mean of 60 and 40, but that's not very important right now. So if you were to simplify this, 1 over 60 plus 1 over 40, that's equal to 5 over 120 if you were to combine the fractions. 5 over 120 is 1 over 24. So 2 over 1 over 24, that's going to be 48 miles per hour. And if you look back at our answer choices, that is going to be choice B, and that would be your answer. Yeah. So I guess this is a very common classic kind of question. Like it turns out like you can repeat the process for general numbers, and you can find that in general, the answer is going to be like 2 over 1 over R1 plus 1 over R2, where R1 is the rate going there and R2 is the rate coming back. Turns out that's like actually a general formula for the average speed. But that assumes that the distance is constant. Like you have to travel the same distance going there and coming back. And one interesting thing about the problem is like it turns out the average isn't just 50. You don't just do 60 plus 40, 100 divided by 250. Yay, answer C. Like clearly that's not the correct way to do it. Like the proper way to do it, if you were to actually like do the math, it tells you that it's actually 48. So this is actually a very tricky kind of question. If you've never seen it before, you might like be tricked to just pick 50 because 50 is the average of 60 and 40. But if we actually do the math, we get like 48 is the answer.